For this little warm-up, I'm gonna post up back here so I can run the decimals graphing calculator. So my first equation was 4x plus y equals 1, right? Then the next one was x plus 2y equals 9. Oops. There we go. So here's our two lines. And what you were tasked with doing is making the first line into some equivalent equation. So I want one group to give me an equivalent equation. Finn, what's yours?
8x plus 2y equals
8x plus 2y equals 2? Interesting. So you multiplied everything by 2. I want another one.
X plus 1/4 y equals 1/4.
So you divided everything by 4? Interesting. Ellie.
4 minus 3 equals 1 if you found out what everything.
Well, we're not solving. We're just changing the first equation to a new equation. Will Baker, what you got?
36x plus 9y equals 9.
So you multiplied everything by 9. Okay, I'm about to go crazy.
Here, I got one.
100x.
I got one.
400x, 400x plus 100y equals 100. What do you guys notice is true about all these lines? They're all the same. So if I wanted to take 4x plus y equals 1, how many different equations could I make that into? Infinite. And that is a big idea we need to use today as we try to do elimination. Because maybe now we're going to have two lines that look like they don't cancel, but we can make it cancel by using our big ideas that if we make an equivalent equation, the new equation is also true and the same, and then we can use it. So keep that in mind as we look on today. Yeah, Raymond. Here is a system, the same system we were just graphing, and it's going through the steps Elena is taking to solve it. What I want you to do in your group is identify her first two moves that she did, and then complete solving to make sure you get the same answer as her. So first, what did Elena do? What are the two moves she did? And then continue to a solution, please. So let's take a look. Elena, to go from here to here, Bob, what'd she do?
She multiplied.
She multiplied everything by 4, right? Right there. And that became that equation right there. Emmett, then what'd she do?
Well, she subtracted both of them, but
Yeah, she subtracted.
I had a question.
Yeah.
If she multiplied everything by 4, then how does the top one stay the exact same?
Well, she didn't mess with the top equation, only the second equation. And she did this with intent, because watch what happens when you subtract. 4x plus 4x is gone. Now, here's the number one mistake that I see. I personally am a multiply by negative 4 fan.
Exactly.
But here's the number one wrong answer that goes right here. Sometimes kids will write 9y. It's y minus 8y. Just make sure you're at negative 7y there. And then 1 minus 36 is negative 35. So this is all good. Now, if negative 7y is negative 35, how many answers are there now that satisfy the equation? 1. And that number is? 5. And once I know that y is 5,
Oh my God, you spent the entire time
plug it in. And now I can solve for x. So 4x is negative 4. What is x? Negative 1. Which means the solution to this system. There we go. We're going to plug it into the original two equations. Which equation should it work in? Both, because this is where they cross. So I put a negative 1 in here. I get negative 4. Negative 4 and 5 is 1. Put a negative 1 in here for x. Negative 1 plus 10, 9. It works in both. Elena did it.
Good job, Elena.
We have a new system, okay? Diego is in now. He wrote this equivalent from the first step. What's the move he made to go from his original to this? What's the move he made? Did he mess with the top one? So he only messed with the bottom one.
Multiplied by negative 5.
Yeah, this is what I like to do. So he did a little different than Elena. He multiplied by negative 5. And that's my move. Because I like to just always add, even though it's the same thing. So if we add these together, then that'll eliminate. Now, if you multiplied by 5, still works. You would then just subtract. With your job on your vertical workspace, please get the solutions for A and B. When I add these together, the result is negative 18a.
18.
Sorry, 28a. Equals
Negative 70.
negative 70. And now I have one variable. I have one answer. A is divided by 7. 10/4, 5 halves.
Wait, what? Divide by 7.
I was just telling you the process I used it quick. I saw that they are both divisible by 7. And then I went to 10/4, then to 5 halves in my head. Then, how do I find B?
You just substitute A for
Yeah.
A.
Substitution. So 12 times 5 halves plus 5b equals negative 15. 30 plus 5b is negative 15. Subtract 30. And that means B has to be negative 9. Question. Will this ordered pair work in this equation?
Maybe.
Yes.
Yes.
Will it work in this equation?
Yes.
Yes. Will it work in this equation? Yes. What you're going to do right now, on your own, at your normal seat, is you're going to work on solving all three of these systems. What I want to draw your attention to, I'm not going to tell you what to do, but I just want you to notice that this one says y equals. I also want you to notice that there's nothing just slapping you in the face to cancel here. We're going to have to do something. But the good news is we know we can take any equation and make an infinite number of equations out of it. If we do it with purpose, we can always get something to cancel. So I'm going to give you 7 minutes to work on these three back at your normal seats. All right, y'all. Regardless of where you're at, we're going to get after this. So attention up here. Maybe have a pencil in hand in case you need to make a change or note something in your work. Maybe that was different if something wasn't right. So this first one, I see a y equals, which is telling me I need to use substitution. Needs a strong word. Substitution is just kind of saying, do substitution. You guys see that? Remember I showed you the other day you can do elimination if you really want to. But so if y is 2x minus 11, guess what y is where they cross? 2x minus 11. Where they cross, y is y. That's the reason we can do this. If I distribute, I get this. I combine like terms to get 7x minus 22 is 18. 2 steps to get x alone. And a lot of people got this right, but then question themselves.
Yeah.
X is 47ths.
Oh.
All right, that's cool. You can keep it 47ths. So then I'm going to go up in here. Y equals 2 times 47ths minus 11, which means y is 87ths minus 11. And I'm actually going to go mixed number here. That's 11 and 3/7 minus 11, which is 3/7. So the place I cross is 47ths, 3/7. Or,
I realized I did more work than I should have accidentally.
yeah, don't get freaked out by fractions. It all worked out like pretty well with fractions still, okay? I like to keep them improper, but did you see how going mixed number helped me do my subtraction actually? I didn't need a calculator. In fact, sevenths in a calculator are going to be pretty ugly. So, yep. So let's jump to we'll do the second one real quick. I know I told you guys to do the third one next. The second one, you guys see those x's just canceling each other if I add?
Yeah.
So that means 3y equals 40. We good there? 3x minus 3x, gone. Negative y, positive 4y, 3y. Oh, that's a negative 17. I done messed up. 3y doesn't equal 40. Oh, yeah, there we go. It's 6. That's much nicer to mess with. So y is 2. Once I know y is 2, it doesn't matter where you put it. I'm going to put it right there. 2 steps to get x alone now. If 3x is negative 15, what is x? And what this means is negative 5, 2 is true for both of these lines. It's where these two lines cross. Remember, the reason I could add is because left side and right side are actually the same. Same thing to both sides. Now this one, there's more than one way to do this one. I got 3 quick ways. Who can tell me one way they got something to cancel on the third one? What's one way? All right, Raymer.
Multiply the top one by 3.
Multiply the top one by 3. I've seen that today. And you got 6x plus 9y equals 45. And when you add them together, these canceled, right? Okay. Anybody do a different way? Because I could think of 2 other ways. Yeah.
I multiplied the bottom one by 1/3.
Yeah, or divide by 3.
Yeah.
And that would give you x minus 3y equals 6. When you add those together, look what happens to your y's. I actually like that method. I got smaller numbers to mess with. I like that. Does everybody see that? Divide by 3. There's another way that works pretty well. Yeah, well?
I multiplied the top one by 1.5.
Yeah. So multiply up here by 1.5 or negative 1.5, depending if you want to add or subtract, right?
That's true.
So if you multiply by 1.5, we get 3x plus 4.5y equals half of 15, 7.5, 22.5. And look at what's going to happen with your 3x's if you subtract. So it doesn't matter which way you did it. You get the same answer. I'm going to go with the divide by 3 route here, which is x minus 3y equals 6. Just an organizational thing I like to do. I like to put one simple line through the equation I changed so I can still see it. But when I add things together, I don't want to add that. You guys see what I'm saying? So 2x and x, 3x. My y's cancel, equals 21. So if 3x is 21, what does x equal?
7.
X is 7. And what's kind of nice, this is kind of a nice equation to put it into because there's no coefficient. So I have 7 minus 3y equals 6. Subtract 7. Negative 3y is negative 1. Divided by negative 3. Y is 1/3. For 7, 1/3. Fractions continue to be our friends. So as you do your homework and you do any of this, big idea. I can make any equation can be made into how many new equations? Infinite. And if we do it with intent to get something to cancel, mathematically it's accurate because if we do the same thing to both sides, new equation is exactly the same equation. Isn't it kind of cool? Like, if you know enough about numbers, you can just make them work to do the things you would want to achieve. Like, it's kind of cool, right? Yeah. Any system you can get stuff to cancel because any equation we can make into a new equation. It's kind of cool. It's like a lot of, I feel powerful. I'm like the Thanos of math when I'm doing this. That's what I feel like. If I could imagine, I'm big and purple and good at snapping fingers. So let me hand that homework out.